Hello, my name is Thales Souza and Associate Professor at Federal University of ABC. The paper we presented is titled as Electric Vehicle SOC Estimation on the Urban Roads of Large Cities Employing Traffic Co-Simulation and Real Mobility Data. This presentation was divided in some topics: motivation, objectives, ideation, estimation model, case study, and conclusion. To motivation, we consider some topics: the penetration of electric vehicles in most parts of the planet is still incipient. The second one is the increase in the EV's fleet can have consequences in the electrical grid transport and communication. The typical dynamism of EV loading can impose bottlenecks, especially at the grid distribution level. The state of charge of the batteries is a variable of interest and very sensitive to the driver's behavior. And the fifth, the high recharge time required and the limited autonomy impose great anxiety on the owners. Consider this motivation, we define the object of this paper. The main objective of this paper is determine the SOC of EVs on the urban roads in large cities where electromobility simulations feed an algorithm integrated into a geographic information system. To validate this proposal, 6 different scenarios are considered, where heat maps and sensitivity analysis show how it can be used to estimate locations likely to receive recharge demand. The ideation of this paper is consumption, impact factors, and modeling. This impact factor is related to internal and external variables and related to 4 characteristics or variables: vehicle, driver, traffic, and environment. The result of the consumption model of an EV is related to the battery, where the purpose is to know the SOC. And the calculation engine, the SOC must be expressed for each road where the EV circulates. Consider the entire path traveled between its origin, departure, and its destination, the arrival. For the model estimation, the flowchart of the proposed methodology is represented by 2 modules. The module 1, open access input data feed a mesoscopic transport modeling run through ISUN software to determine the pattern of electromobility. And module 2, an SQLite database provides trip information for all vehicles modeled for an algorithm. This model is associated with the GIS to obtain a special database with the SOC along the roads in the study region. Consider the estimation model. The SOC calculation, 3 steps are considered. To SOC calculation, 3 steps are considered. First one is pre-processing, the second one is calculation loop, and the third is finalization. The pre-processing, the data are compiled and prepared to recover the trajectory, time, and speed by section for each vehicle. The calculation loop, an initial SOC is assigned to each EV, which is randomly characterized. During the path, the SOC is updated until it reaches its destination or until it reaches the minimum limit. The minimum limit is a sensitive variable that can be parameterized. And finalization, the information is compiled and an average SOC data frame per section is created. To the case study, we consider Salvador in the state of Bahia, of the largest capitals in Brazil, located in the northwest of the country. The EV penetration rate was estimated at 7%, Two models of electric vehicles were considered in the fleet: Chevrolet Bolt and GAC EV40. In this table, we represent the summary of the test performed. We consider six tests: scenario 1, scenario 2, and fourth sensitive analysis tests. For each test, we represent three periods: the 6 to 8 a.m., 12 to 2 p.m., and 6 to 7 p.m. We consider different initial SOCs and fixed minimal SOCs in 25%. In these maps, we can represent the variation of charges in the different periods. For example, 6 to 8 a.m. for scenario 1, we can see yellow and green lines. To 12 to 2 p.m., we can see uh, yellow lines, and 5 to 7 p.m., we can see red lines. It represents that in different periods we have the different charge to EVs. And to scenario those, the same idea. For the first one period, the IV is more charged. The second period is less charged, and the third period the EVs are discharged. Uh, these figures represent the sensitive analysis for the SOC range. The first one represents the diagram of extremes and quartiles, and the second figure represents the frequency distribution histogram. In the conclusion, the present work presents a model composed of two models for estimating the average SOC of EVs on the road in large cities. The simulation provides all EV trajectories, time, and velocity to feed an algorithm that provides these readable red maps and special database. The model was tested in one of the largest Brazilian capitals, considering a global penetration of 7% of EVs. Six different scenarios were considered, and a sensitivity analysis showed how the initial SOC range influenced the results. A possible application is determine appropriate locations for the installation of charge as well as the expected electro demand. Thanks for your attention.